Welcome to the click. This is comparison of power numbers. So we have two types of comparing powers. First, comparing powers with positive bases, and second, comparing powers with negative bases. Let's analyze both. So comparing powers with positive bases, first of all, try to rewrite them so that they have the same base or the same exponent. This makes it easier to determine which expression is larger or smaller. What do we mean by rewriting? So for example, if we have 4, try to rewrite it as 2 to the power of 2. This makes it much more easier, especially in comparisons. Maybe you assume that instead of all these rules, why don't we just write the number to its power and then write the result? So for example, if we have 2 to the power of 2, why don't we just turn it into 4 and then compare it? These rules are for when the number is large. When the number is so huge, at that time, it's very hard to turn it into a regular number. So that's why we are considering these rules. So you firstly rewrite it, and then after rewriting, you memorize these rules, okay? The first rule, if we have the same exponent, larger base gives the larger value. If we have the same base and my base is larger than 1, at that time larger exponent gives the larger value. But if I have the same base again, but my base is greater than 0 but smaller than 1, at that time smaller exponent gives the larger value. Meaning if I have 0.5 to the power of 2 and 0.5 to the power of 3, 0.5 to the power of 2 will be larger, okay? So yeah, this is comparing powers with positive bases. Let's do some examples now. So for example, I have 32 to the power of 3 and 2 to the power of 12. First of all, let's rewrite them. So 2 to the power of 12 is very simplified, but I can simplify 32 to the power of 3. So it can be 2 to the power of 5 all to the power of 3. And this will be 2 to the power of 15, and 2 to the power of 15 is the same as 32 to the power of 3. Right now, I have 2 to the power of 15 and 2 to the power of 12, right? So right now, it's very much simplified. I have the same base. I am going to just compare the exponents. As I said, in positive bases and the bases that are greater than 1, at that time, the larger exponent is the winner and it's greater. So 2 to the power of 15 is greater than 2 to the power of 12. Okay, this was the first example. Let's do another one. So I have 0.6 to the power of 3 and 0.45 to the power of 3. What am I going to do? I will look if I have the same exponent or the same base so that I don't need to rewrite them, right? As I can see, I have the same exponent, so no need for simplification. All I need to do is that I will bring them into a competition, okay, and see. Because we have the same exponent, okay, we have the same exponent, so we know that the larger base makes the greater number. So we know that 0.6 to the power of 3 is greater than 0.45 to the power of 3, as 0.6 is greater than 0.45 as a number. So these were the examples. Let's go for comparing powers with negative bases. First of all, rewrite, of course. Second of all, determine whether the exponents are even or odd, the powers, whether they're even or odd, since this affects whether the result is positive or negative, which helps you with determining the larger number very quickly. So yeah, we have another memorization. So if you have the even power, at that time positive result will happen. If you have odd power, at that time your result will be negative. But if you have both negative and odd powers, at that time the positive result, meaning the even power, is always the winner, okay? Because even power is always greater than any negative result or any odd power. Even power is greater than odd power, okay? These were the explanation, but we won't actually learn it without doing any examples. So let's do it. So for example, I have 1 divided by 5 to the power of negative 2. And also 1 divided by 5 to the power of negative 3. What I'm going to do, I am going to rewrite it so that I can make it simplified. So I can write this as, let me see. So I have 1 divided by 5. I can write it as 1 big parentheses open, 1 smaller parentheses open, 1 divided by 5 to the power of minus 1 all to the power of 2. Because minus 2 is the same as minus 1 times 2, right? Because these two will multiply. And the same with this one. Big parentheses open, smaller parentheses open, 1 divided by 5 to the power of minus 1 all to the power of 3. Okay, right now I have even powers. All of them are to the power of an even power, right? And what I can do is that because my power is negative, I can reverse the placements of 1 and 5 to make the power positive. Okay? So, meaning that if I have 5 divided by 1, this will make this power, which is negative 1, a positive 1. And then when this positive 1 is multiplied with 2, it creates 5 divided by 1 to the power of 2. Or basically, 5 to the power of 2. Okay? So it's very much simplified. See, from 1 divided by 5 to the power of minus 2, it has turned into 5 to the power of 2, right? And the same with this one. This one, 1 divided by 5 to the power of minus 3, it's going to be 5 to the power of 3. So because I have the same base and it's greater than 1, the larger exponent makes the larger value as we studied. So 5 to the power of 3 is our answer, everyone. And we are done with today's lesson. I hope you got it. Just remember, make everything very simplified for you. All we talk about is simplicity. Make it simplified, and then mathematics will be just like drinking water. Thank you. Sources page.